and also I work as a part-time contributor at the University of New Mansoura. Okay, let's take an overview of the outline for the presentation. Number one, the introduction, the Egyptian context, purpose of the study, research objectives, significance of the study, the conceptual framework, hypothesis, data and methodology, findings, and at last, implications. Introduction. The digital economy and energy structure have significant impact on carbon emissions in Egypt. Digital economy helps to reduce emissions, while the energy structure, particularly the reliance on fossil fuel, contributes to increased emissions. Several significant trends and development define Egypt's energy structure. Natural gas has traditionally been at the heart of Egypt's energy framework, being used for power generation and industrial applications. Oil also makes a substantial contribution to the energy mix. In the context of renewable energy, Egypt, with an increasing focus on sustainability, has been proactively engaging in renewable energy initiatives, especially in the fields of solar and wind power. Despite initial investment in renewable energy, Egypt's focus remains heavily on fossil fuels, particularly natural gas, making it a significant consumer and producer on the African continent. Domestically, Egypt views fossil gas as a transitional energy source and intends to expand its utilization across different sectors of its economy. However, recent geopolitical events such as the Ukrainian invasion have prompted Egypt to notably increase its fossil gas exports to European nations. Egypt aims to establish itself as a vital energy hub in the region. Nonetheless, this strategy risks locking Egypt into a high carbon path, highlighting the urgent need for a comprehensive shift away from fossil fuels to compete climate change effectively. The Egyptian context. Egypt provides an interesting case study due to its unique socio-economic circumstances, expanding digital economy and significant energy challenges. The country's continuous digital transformation, along with the ambitious economic reforms, creates a fascinating context for examining the interplay between digitalization, energy dynamics, and carbon emissions. Elements like Egypt's geographical position, energy infrastructure, and socio-political climate influence its energy composition and carbon emission trends, offering valuable perspective on wider global patterns and concerns. This makes Egypt a valuable reference point in the study of energy and emissions in the context of digital transformation. The purpose of the study is exploring the transformative impact of digitalization on energy dynamics and carbon emissions. It studies how technological advancement and increased connectivity in the digital economy have developed the industry and daily life, leading to a consequential demand for energy. This demand for energy is often met by infrastructure that rely on energy sources contributing to carbon emissions, thus raising concerns about their environmental footprint. The research objectives. The objective of the study is to investigate the impact of the digital economy and energy structure on carbon emissions within the Egyptian economy over the past 3 decades. The significance of this study lies in the potential to inform sustainable development pathways by leveraging opportunities presented by renewable energy, energy efficiency, and digitalization. Egypt can move towards a more sustainable and resilient future. This study is providing insights that could guide policy and decision making in the context of environmental stewardship and economic growth. The conceptual framework. Let's look at the first variable, digital economy's broad spectrum. It involves the integration of digital technologies into various sectors, revolutionizing traditional business models, communication channels, and consumer behaviors. The second variable, which is the dependent variable, it's the impact on carbon emissions. Digital technologies, when deployed across sectors like energy, manufacturing, and transportation, have the potential to reduce global carbon emissions. However, the energy consumption associated results with digitalization, for example, like cloud computing and artificial intelligence, must be carefully managed to avoid unintended environmental consequences. The variable of the energy consumption patterns, which is the explanatory variables, the adoption of the digital technologies alters energy consumption patterns. For instance, data centers and communications network require substantial energy input. This shift towards renewable energy source is crucial to mitigate the carbon footprint of digitalization. The hypothesis of the study, H1, there is a significant effect of the economy on carbon emission. H2, there is a significant effect of energy structure on carbon emission. The data and methodology data was driven from World Bank website for the time series 1990 to 2020. The primary response variable under examination is total carbon emission in kilotons. The explanatory variables are categorized into two main components. The first one, those reflecting aspects of digital economy and those indicative of the energy structure within Egypt. Specifically, the former comprises indicators such as individual use of internet and technical cooperation grants, while the latter is represented by the total renewable energy consumption. The study findings, the first one, individual internet usage. In the short term, individual internet usage doesn't exhibit a discernible impact on carbon emissions. However, in the long term, the individual internet usage has a negative influence on carbon emissions. This suggests that while immediate effect may be minimal, but sustained digital activities can contribute to emission reduction over time. The second one, technical cooperation grants. An increase in technical cooperation grants corresponds to a reduction in carbon emissions in the short term. This finding reflects the role of international aid and technical assistance in promoting cleaner technology and practicing leading to a lower emissions. The third one, renewable energy consumption. There is a negative relationship between renewable energy consumption on carbon emission. The negative correlation implies that an increase in renewable energy adoption contributes to emission reduction over the long term. And last, the implications, the study's findings contribute valuable perspective on sustainable development and environmental stewardship. The price correlation analysis and subsequent regression models indicate a clear relationship between digital activities and carbon emissions, as well as the influence of energy structure on these emissions. The analysis suggests that investment in digital technologies and clean energy solutions can drive economic growth while minimizing environmental degradation. International cooperation facilitated through technical cooperation grants and knowledge sharing emerges as a crucial component of global climate action, enhancing capacity building and promoting technology transfer. The error correction model reveals co-integration among the variables, implying a stable long-term relationship and the potential to accelerate progress toward carbon reduction targets. And that's the end. Thank you.